All right, we're going to talk about one more thing today. Area is pretty simple, so we're going to tag in one more thing. We're going to talk about the Pythagorean Theorem versus the converse of the Pythagorean Theorem. Now, when I ask people what the Pythagorean Theorem is, almost unanimously, people shout out a brief little formula. But you guys are all geometry students, and you should know when you hear the word theorem, almost every theorem is an if-then statement. So how do you say that little equation as an if-then statement, or how in the world would it be an if-then statement? And then also, what would be the converse of that? Well, if you don't have something already with which to write and on which to write, please get those things out, because we're going to take just a little bit of notes, not much. Okay? Well, first of all, the Pythagorean theorem actually says this. It says that if a triangle is a right triangle, then the side lengths A, B, and C will always fit into the equation a squared plus b squared equals c squared. If you have a triangle and it is a right triangle and the side lengths are A, B, and C, and we'll just to clarify, C is always opposite of the 90-degree angle. That makes this side called the hypotenuse. So if the side lengths of a triangle are A, B, and C, and it's a right triangle, then those three numbers will always fit into this formula, this a squared plus b squared equals c squared. Now let's think about what the converse of that would be. Now, you guys are really good at conditionals and converses, and so to spin that around for the converse is not that challenging. The converse is right here. Okay, a little sloppy, but it's still here. And it says if the side lengths A, B, and C of a triangle fit into that equation, a squared plus b squared equals c squared, then it must be a right triangle. Okay, so now here what we're looking at is we're going, okay, I have some triangle and I've got the sides A, B, and C, and I'm unsure whether it's a right triangle or not, but I have these sides. We're saying if it fits into this formula, then we can be certain that it is a right triangle. So that's really what the Pythagorean theorem is and what the converse of the Pythagorean theorem. The Pythagorean theorem says, hey, if you got a right triangle, then the side lengths A, B, and C will always fit into this formula. And if you have any triangle with the side lengths A, B, and C, and they fit into this formula, then it must be a right triangle. Okay, so what we're going to do is we're going to play with this idea for a second. My expectation is that most of you probably have some knowledge of the Pythagorean theorem. So now I want to do a little bit of the converse, and let's kind of think through that. So here's three triangles, and I've given you some side lengths. Okay, there's only one thing. I'm going to change this one right here. But otherwise, we're going to say these are the side lengths of these triangles. What I would like you to do is to determine whether any of these or all of these or some of these are right triangles using the converse of the Pythagorean theorem. Meaning I can take the three sides, plug it into this formula, and if it's true, then it must be a right triangle. Okay? So go ahead, we're going to pause the video right here, and I want you to try it for all three of those. All right, let's take a look. For this first one, I would say, now, the one thing I didn't make clear, I did talk about the hypotenuse being opposite of the 90. The thing I forgot to make clear is the hypotenuse is also always the largest side. If two things are going to be squared and add up to be the third thing must be the biggest one. So in this first scenario, I would say 4 squared plus 7 squared equals, put a question mark there, 8 squared. The 8 is going to be by itself because it's the largest number. And this is 16 plus 49 equals 64. But 16 and 49 is 65. And that does not equal 64. Even though it's really close, this is not a right triangle. Okay, let's look at this next one. You would go 5 squared plus 4 squared equals 7 squared. Now, it doesn't matter the order of these first two, just so you know. 5 squared is 25, 4 squared is 16, 7 squared is 49. 25 and 16 is 41, and 41 does not equal 49. So again, not a right triangle. And then let's try this last one. 6 squared plus 8 squared equals 10 squared. 6 squared is 36. 8 squared is 64. 10 squared is 100. 100 equals 100. So what do I know? This one right here is a right triangle, okay, by the converse of the Pythagorean theorem. Because the side lengths fit into that formula, then it must be a right triangle. Now that's pretty cut and dry and pretty simple, okay? We're going to do two more things. What I want to do is, let's talk about, first of all, let's talk about what happens when it's not a right triangle. Okay, because there's always going to be one of two things. Look at these first two instances. Here, 65 was too big. It didn't work. 64 was too small. Here, 41 was too small, and 49 was too big. And I want to focus in on the hypotenuse number. Okay, I want to focus in on that number real quick. And let's take a look. Let's think about, here's my right triangle. And I got A, B, and C, and it's a right triangle, and it fits wonderful. But what happens if I have this situation right here? And C is not long enough. And C is not long enough. So that means that that number, that would be like this situation right here. The C value is not big enough. Okay, so right here, the C value is not big enough. What kind of triangle would that have to be? Well, I would have to move this angle this way to make those sides connect, which would make it smaller than 90, so it would be an acute triangle. So in other words, if C, the hypotenuse, is too small, then I'd have to close in that angle and make it an acute triangle. So if the hypotenuse is too small, it's an acute triangle. Now let's think about it the other way. What if the hypotenuse is too big? And that would be like this situation right here. Here, the number that was all by itself, it was 49. That one's way too big. So what would happen there? Well, now you can see in this situation, I'd have to open this angle up bigger than 90. So if the hypotenuse is too big, then this must be an obtuse triangle. So when you're doing this, you can establish, wait, if the number that they're not equal and the number that's all by itself was too big, then this must be obtuse. Okay, so we can classify triangles. So we can determine if triangles are right triangles. We can determine whether they're acute or obtuse. And lastly, we should be able to find a missing side. If you have two sides of what you know to be a right triangle, then you should be able to find the third side. Like for instance, on this first one, I could say 4 squared plus 5 squared has got to equal C squared. 4 squared is 16, 5 squared is 25, equals C squared. So this is to say that 41 is equal to C squared. Now, C is not 41. I have to take the square root of both sides. C is equal to the square root of 41. Now, I don't want you to tell me that that's 6 point something ugly. It's not. It's just the square root of 41, plain and simple. Okay? All right, I would like you to try these two. We can pause the video right here, and then we'll see if you got them right. Okay, let's see how you did. Now notice these are both a little bit different. I have to say 9 squared plus d squared equals 12 squared. I don't get to add the 9 and the 12 because the 12 is the hypotenuse. So this is 81 plus d squared is equal to 144. I subtract the 81 from both sides and I get 63. So therefore, then I take the square root of each one, and d is equal to the square root of 63, which doesn't come out clean. So that right there is the exact answer. And then lastly, let's take a look at this last one. Okay, we've got e squared plus 7 squared is equal to 13 squared. So that is to say that e squared plus 49 is equal to 169. Subtract the 49 from both sides, and I get that e squared is 120. Take the square root, and I get e is the square root of 120, which again, really close to a whole number, really close to 11, but it's not. So that's how I leave it. All right, we're going to do a little bit of practice on problems like this where you're going to have to do these things. You're going to have to determine if a triangle is a right triangle or classified as acute or obtuse. You're going to have to find missing sides. And you might even combine that and do something with area that we already know. Okay? You guys will be fine, and you'll get it.